And welcome to this webinar where today I'm going to be talking us through how we can utilize AI ethics in the Microsoft Data Platform. So why am I giving this talk? I'm going to loosen a bit more to it as we go through, but it's become more and more evident to me that as AI becomes more intrinsic into our day-to-day work life, maybe we're getting too keen to get hold of it, and we're missing what is intrinsic to me as an AI engineer in terms of the ethics of how we use AI and where you can be really tripped up implementing AI in our workflows, in our data sets, without contemplating certain aspects that can happen. So before we really get into it, a quick chat about who I am in a bit more detail. So I'm Lewis Prince. I'm a senior AI engineer at a company called Purple Frog Systems. We're based in the UK near Birmingham on the Welsh border, and we really do anything end-to-end data-wise, so data ingestion, ETL systems, if Fabric, Power BI, Synapse, as well as more advanced analytics such as AI and predictive machine learning algorithms, etc. I also, in my side time, I'm a co-organizer and co-founder of FabFest, which is a Fabric and AI one-day conference in Telford, based in Birmingham. We do in October every year. So if anyone's interested in going to that as well, we can post some links in a bit, and you can discuss me afterwards. And as well as that, on a monthly basis, I co-organise the West Midlands Microsoft Data Platform User Group. So I'm presuming some of you may have come to that as well. It's where you may have picked up from. So that's anything to do with data on the Microsoft Data Platform. We get speakers from around the world come in and give really valuable knowledge in that platform. In addition to this, I'm also a Microsoft AI MVP, which is kind of presented and awarded by Microsoft on a yearly basis for people who go out and really give the community in their respective tech stack. So for me, for the AI, Microsoft Boundary Space, the Copilots, and really gives me inside knowledge in terms of where the industry is going, as well as enabling me to impart my knowledge and get knowledge imparted to me by people really at the top of their game. And finally, I'm also Microsoft certified data scientist and AI engineer associate. I'd also love if you will connect with me with LinkedIn. So the top link will go to my LinkedIn. You will find my blog on there as well. I blog quite regularly under the pseudonym of the Data Rhino. So if you would like to connect with me there, I would love to have a chat to you outside of this platform, as well as a link there in the set QR code to Purple Frog Systems Frosblog. So anything to do with AI, I will blog on there, as well as anything to do with the whole data ecosystem. I'm sure if you could think of it, you've had a problem with it, someone within Purple Frog Systems will have made a blog about it. And so it's quite a great resource for anyone to have. So how are we going to tackle this today? So my plan, I'll first talk through why AI ethics is now practical. I mean, like practical for all. Why is it important that everyone in the data industry has a grasp of AI ethics? We'll then discuss in detail where ethical risks can enter your data solutions. So where are the most common avenues where you can have ethical bias come into your data sets and where you need to keep an eye out for it. We'll then go through a live demo. So this is where looking at a data set that I have got manufactured in terms of where we can see bias in action in our models and where that can be amplified by AI in our automation. I'll then talk us through a practical decision framework. Now, this is based on Microsoft's responsible AI framework, which is a bit more technical. There's a lot more technical things we can go on in terms of how we can be more ethical and combating bias. But today, I'm going to propose to you a much more practical framework of kind of questions we can ask at certain stages of the data, our data flows, and when we go through our work, in terms of making sure we keep our mind present to what we should think about and asking questions which should elucidate where we may have problems in terms of ethics and bias. I'll then talk about how we can apply that decision framework in Fabric and Power BI. So trying to make it really applicable for the most common data user I could think of at the time, in terms of how we can use that decision framework day to day. So, first of all, a question for everyone here. If you just drop it in the chat, we get to it. But why is ethics important in AI? So, just to get a feeling for what everyone's viewpoint on this, why do we think AI needs ethics imparted into it? It stops misuse, yeah. So, if we keep ethic, it stops us misusing it. It stops people misusing the data that comes out of AI as well. If we're ethical in our application, it stops what's produced from being misused and maybe misinterpreted as well. So that is one avenue of why we need ethics in AI. It's a complex question, to be honest with you. A lot of it's avoiding bias. Yeah, we need transparency. That's a big thing for AI in terms of when we do put stuff in place. It needs to be a transparent system. Black box systems are a thing of the past, really, legally as well. When an AI makes a decision for a company, we have to be able to explain why it's come to that viewpoint and how it's come to that viewpoint and how it's come to that decision. We can't unfairly impact people's lives by applying AI. So transparency is a big thing as well. So I'm going to answer this question over a few slides now, because it is quite complex an answer, and hopefully I impart that into you. So moving on to the first bit, why AI ethics is now practical. So it really has moved from theory to practice. And coming on to what Patricia said originally, AI is embedded into everyday tools. I like to use quite a common Spider-Man quote for this. That we have AI in all our hands now, but with great power comes great responsibility. And that's very much like Spider-Man's powers. There's a lot of things we can do with Claude's, our ChatGPTs. There's a lot of impact we can make, both good and bad, by applying AI. So we need to make sure we're very responsible in our applications. Firstly, because the decisions we make with AI can scale instantly. So usually in the platforms we're using AI within, they're very visible. They're very easy accessible. And usually when you put something in there, it's accessible to a whole business at a time. And people can make choices and decisions off it instantly. So we need to be very sure in terms of what it's outputting is correct, and there's no underlying bias or ethical reasoning why it shouldn't be released when we do use it. And moreover, errors are hard to see. And for anyone who's used things like ChatGPT and Claude, it will be very convincing in his answers. It will back itself up in what it says. And so a lot of people intrinsically trust the outputs of these systems. So we need to not lose our ability to critically think and critically question these systems. And that's a big underlying baseline of what I'm going to talk about today is critically questioning these systems and not falling into what is most commonly known as automation bias, where you intrinsically trust everything your AI says to you because it says it so convincingly and it uses little data points, which at the end of the day, it could make up. So we need to still supervise these models and supervise the outputs. In addition to this, AI is an amplifier, so it's never creating values. So anything that comes out of an AI system, it's basing on what we've given to it. It's based on its training, and it's based on any supplementary data we've given to it. So AI is not creating anything; it's just inferring what we've given to it. So we need to make sure when we do give it to it, it's correct. There's nothing in there which then can be amplified into existing decisions. I'm hoping I've summed this up quite nicely with that image at the top right, where when you give your AI data, it's listening very quietly. It's not going to comment saying, well, maybe this is wrong. Maybe this, you need to adjust this or look at this. It's going to process what you've given to it and they really scream it to your whole business in terms of what choices are made for it and what is seen in that data set. And the bottom line of that is small choices within data sets can lead to large impact. Small choices in how we choose to process our data and how we use AI can lead to very large impacts. And to really put that into consideration for us and to scale, I always like to talk about this great book by someone called Cathy O'Neil. And I read this just after university, Weapons of Mass Destruction. And within this book, there's about 12 different use cases where Cathy goes into where AI has been used, much of the social economic impact of people, to businesses, countries. So there's applications in finance, policing, schooling, um, in the civil services. It really is a really fantastic book in terms of seeing where stuff can go wrong and where people have used and misused AI and to basic level machine learning and predictive algorithms, much to massive detriment of people. And my favorite example in here is something called Predpol. And Predpol was a predictive policing engine. And it was a company which contracted this tool to police forces. And the example they give in Cathy O'Neill's book is it being used in American precincts, American policing. It used historical crime data such as time, location, and types of past crimes to predict where crimes are most likely to occur in the jurisdiction of each police force. And what it would do is on a daily basis, it would create hotspot boxes that police are told to patrol. Now, we know for a fact, well, not for a fact, it's quite well commented on that American police forces historically are quite biased racially in that regard. And when that data was fed in to Predpol, it was obviously based on historic crime data where these police officers are biased in how they're pursuing criminals and how they're arresting certain demographics of people, and that fell into the model. So Predpol was predicting hotspots in largely black areas, more often largely white areas. And what that would mean, you'd have more police patrolling these largely black areas, finding more crime and arresting more people. And that would feed back into the historical crime data, which would then feed into further predictions of hotspots. And it's a very vicious feedback loop that would happen where the bias is amplified by the AI. So we get more and more bias as it went along as a self-fulfilling prophecy, some could say. So as more people were there, they were finding more crime, and that was justifying Predpol predictions because they were by any metric, they were finding crime at a higher rate by doing what they were doing. Obviously, they were ignoring the broader social context and relying on that data produced by prior bias, which wasn't great, and obviously was racially profiling people in that regard. And the problem with that is it's because Predpol was an opaque kind of black box model. The system of priority was largely unaccountable for communities affected by its predictions, and these police forces had very little visibility and how decisions were made on where they should be policing. It was just the fact they were told they should police more in these directions. And yet, even though they didn't really know how to police it, these communities and police forces were significantly impacting people's civil liberties and reinforcing structural inequality via using the AI model. And moreover, these police forces and the cities in which these police forces sat were exposed to lawsuits and federal oversight and very costly settlements, as well as mostly a very big loss of public trust in those systems when it came out that they were using AI to this detrimental effect. So I know that's quite an extreme example, and there are several other kind of just as impactful examples in Cathy O'Neill's book. But I was wondering if any of you have ever seen where examples of bias you've seen out there in data or bias you see in implementations of AI. So much like with Predpol, if anyone's seen that before, it's okay if we haven't. I thought I'd throw it to the floor and see if anyone had any comments on that. It's a hand up from Eagle. If you type it in the chat, Eagle. It doesn't matter if not, guys. I've got the demo today to kind of show an example of where bias have come in. I was wondering if there's some real life examples we could talk about I get onto my own kind of manufactured example. Okay, I'm guessing not. So let's talk more about where ethical risk can enter your data solutions. So I'm going to highlight 4 key areas I usually see ethical considerations need to be kept in mind and where bias can enter your data solution. So the first of all is how your data is collected. That really shapes who appears in it. So, for example, if your collection method favors a certain group of people, behavioral outcomes, the imbalance and bias you impart into it by using that collection method is the foundation everything is built on in that AI model that the data is built from. So, for example, if you are an app or some sort of establishment which has an online and in-person presence, maybe such as Next, any kind of a shopping relay, Currys, PC World, and you're trying to assess customer satisfaction, but you only sent an email out to people via an online portal by people who have bought online, have accounts for your Currys online, you're only really assessing people's satisfaction through your digital portal, as opposed to your in-person people going. And you may be biasing people of a certain generation and age. So your older generation will most probably be going into a shop and doing their shopping in person as opposed to online. So intrinsically, by using that data collection method, you're being biased in terms of age, which you really can't do. Next is your data preparation. So I find that most decision making happens in data. You're trying to make your data set as clean as possible. And when you do that, when you try and clean your data set up, you really are changing what reality counts in your data set by removing outliers, by filtering your edge cases and standardizing data. You quietly erasing group data that matters the most. So it could be the fact that these outliers really are people that need to be in there, and they may soften the edge that AI makes in terms of decision making when you come down to it. It's a very common thing usually when I work with my data engineers or with data engineers in different companies. I don't really like looking at their gold level data. So the stuff that comes into their production systems, I'd always rather have a look at the raw data and see exactly what's come out of the system before it's been cleaned up, before it's been made tidy to be put into Power BI dashboards, etc. Because it really needs to have that context in terms of 99% of the time, I'd keep all outliers in there because I don't want to erase a sort of truth. I don't want to make it clean because there's a chance that I'm imparting bias there via my data preparation, as well as standardizing values in terms of if there's a really strong indicator in certain of those values, and by standardizing, we soften that edge. Our AI system at the end of the day is not going to act as strongly in that avenue. It's going to be very neutral, which in itself could impart bias on certain demographics. On top of that, more technically speaking, as we go through feature engineering, and this is how, from an AI or machine learning point of view, we take our data and we generate what we're going to put into our AI systems, into our models. And we usually use features such as age, how many times someone's visited a store, what their demographic is, what kind of membership they have for a certain thing. If it's a gym, have they got the standard premium or premium plus membership? So stuff like that. But we also get stuff like proxy features. So there are protected characteristics such as someone's wealth, for example, their ethnicity, someone's age. And usually we would not, unless it's a very good reason for using it, use those features in our engineering, in our AI models, because there's laws against that. So someone's age or gender or postcode could be correlated to their ethnicity. For example, with postcode, if you lived in a largely Chinese community, a largely Chinese postcoded area, by using postcode, you would be proxying that feature of ethnicity into your data model, which again, you could bias against a whole demographic of people by doing that. So it's something to keep in mind. And then we also get our automated defaults. This is where once bias enters your data and automated scales, we need to keep in mind that the decisions that comes out of a model where you fed it biased data, it has not failed. It's just exceeded exactly the wrong thing at speed and a volume with no human pause in between that interpretation of the data to make decisions out of it. So it's very clear to keep in mind that when AI does go wrong, it's not the AI that went wrong, it's exactly what we asked of it. We still give it the right parameters, the right context, the right data to make the decisions we want in an ethical and unbiased way. So let's look at an example of where we can see bias entering the data set. So for this example, we're going to use something called Velvet Real Cinemas. So this is a made-up company. Think of it the same as your Cinemaxes, your Odeons. And what Velvet Real's data set is for us is they did a customer survey online. So you have customers which can they can book their cinema tickets in person at the cinema itself, or much like with Odeon, you can book your tickets online. And so what Velvet Real did in this scenario, the demo, is they sent out a survey to get customers' opinions on the system, as well as using the data we have from the app on these customers to realize if they're going to churn or not. So if they're going to cancel the membership or stay with the cinemas to keep paying for their membership, keep paying for their subscription, and keep coming to cinemas to watch films with Velvet Real Cinemas. So the data set is as shown. So from this, we get age, so age band, where in the country they are, what kind of contract type they have, what their product tier is, how long they've been with us, how much they spend monthly, their digital engagement score. So this is set in terms of how well they interact with the app, how many support tickets they've raised to the app over the last 12 months, and then if they left or not. So the churn is a 0 if they've stayed, or 1 if they've left. Now, we could take this data set as it is and put it straight into an AI model and get it to help us predict in the future if our customers are going to leave or not. And if we did some quite rudimentary analysis of this and made decisions off our own back, we could get something like this. So in this data set here, we've got the count of how many people have churned via certain demographics. So we've broken down by age band and region. And so the first two big things you can see, and I'll go into actual numbers in a bit, is that we have not many people being polled for 66 plus. So as age goes down, we're not going to as many people responding to that survey where we have data on for this bit of work. And you see we've got a lot more people in the south as well. But it's a good notion the amount of churns between these populations as well. There's a lot more churn within the south region and the 66 plus, which doubles up here in the amount of churn rate. So you see that 66 plus has nearly double that of the 18 to 35, the 36 to 50s. And if we were looking at 51 to above, it's over half the population churn in those demographics. So that would be quite a strong indicator to me, and it would be quite a strong indicator to AI, that age being a very big factor in terms of how it was going to make decisions in the future via a model we make from it in terms of which of our customers will churn or not. In addition to this as well, if we were looking, we'd say if someone was in the southern region, they're much more likely to churn based on popular behavior and the data we have on them. It's roughly double to a degree-ish than north and west, and a decent amount higher than the east as well. So if we were going to feed this into a data model, into an AI, our predictive analytics, it probably would come up and say, well, people in the south at the 66 plus, they're probably going to churn, and that's something an AI model will come back with. And we know for a fact there's bias in that. So it could be the fact that we're being biased on age. We can't do that anyway. So we might get rid of the age band as a feature. We can feed that straight in. And you might think we've fought against bias in that regard. There's something called proxy variables as well we haven't thought about. So if we were to feed in our digital engagement score and show the average digital engagement score by age, you can see that digital engagement score is acting as a proxy for age, as an approximation. Is that as the age gets higher, the average digital engagement score lowers, which makes sense. As I said earlier, a lot of people of that generation, an older generation, are much preferred to go in person to the cinemas, to put a ticket in person, as opposed to using an app. They're quite tech phobic in terms of what they're doing. So that's something to keep out for. If we were just to feed in this data as it is, without kind of doing any investigation into what biases could be introduced by doing this, you leave yourself open to intrusion bias to your data sets. So let's explore this a bit further in terms of why does this happen. So we've got collection bias there. So straight away, we chose to use a digital way of capturing our data. For example, we know, looking at the back of this, it's hypothetical again, but in the data set I've shown you, 12% of that data set were 6 years plus customers. But in reality, if we went and looked at people that turn up in person, it's actually a good around about a third of the population with those 6 plus. So we've lost half of that data set there. So that 6 plus we're looking at is not a real representation of actual churn rate, because we haven't given the AI model context. We then be biased to those 6 plus customers. Then we also get temporal artifacts in terms of when we did this survey, hypothetically again, the churn rate in that southern region was a one-off service disruption. So what was actually happening, hypothetically again, is that the app that in the southern region, the servers for the southern region supporting them was down for a lot. They were seeing a lot of problems on the app, and so that's what we're seeing reflected. So it wasn't a real human behavior; it was very driven human behavior because of what they're seeing in the app. And we spoke before that we saw proxy variables in terms of digital engagement score encoding age and not risk. And we were very much hiding the survival bias. So these 18 to 35-year-olds kind of coming through by having that digital engagement score in terms of keeping that very high because they engage so much with the app and inferring that to the churn rate. So how can we map that back to the 4 sections I mentioned earlier? So we've already mentioned this briefly. The customer data was captured via a web portal. And so our 6 plus customers who never really use the app are almost entirely absent. We missed half of them. So the portal, it captured cancellations well in the 6 plus, but it's not capturing the loyalty poorly because of the way we source that data. Further on to this as well, in our data preparation, again, we couldn't see this, but before it came to us, our data engineers had removed outliers and filtered unusual values silently. So removing very long tenure, low spend 6 plus customers, but didn't fit the average profile of the 6 plus customers. So again, this may have softened the blow in terms of how aggressively an AI model may have predicted those 6 plus customers churning more than any other age group demographic. And again, we tried to be as ethical as possible and not let the model do predictions via age, but we let a proxy variable get in there via that digital engagement score, which kind of makes sense when we think about it. Without stopping and thinking, we may have let that in and been biased. And so if we were going to feed that directly in, we'd know that our churn model we create from that data set will confidently target 60 plus 6 plus Southern customers for retention spend. And this is the very group that may well be the most loyal in our data set. So the automation, so the churn model we make, do exactly what the bias tells us to do. So it kind of accentuates the fact that if we introduce bias into our data sets, we introduce bias into AI as well. So we may say now, well, we're probably not going to look at this ourselves. And what if we just put a data set through Claude or ChatGPT to check for bias beforehand, or to check for what it's going to do? A normal question may be just ask Claude what demographic is most of the churn. We may not even make a predictive model. We may just go into this, get our Excel, and go to Claude to ask it who's most likely to churn from this data set. Because at the moment, all we've done is look at ourselves, have a brief overlook, and make our own assumptions. And you may think that something like Claude or ChatGPT would be able to spot these biases, but it doesn't. As we can see here on the right, I've asked it what demographic is most likely to churn based on our data set. It comes to the same conclusion we have by looking at that. And it goes into a bit more detail in terms of other variables it would look at, such as the monthly contracts, what tier they're on. It does, again, looking at age for the low engagement score, and how many support tickets they've raised. So it kind of goes to show as well that Claude as well can mess us up, and we'll fall into that trap. So it's not just the more basic predictive algorithms and predictive models we feed our data set into that can be tripped up by us introducing bias into our data sets. It happens as well to the much more complex, what we think much more trustable, big, large language models that we're using day to day currently, such as Claude or ChatGPT or our Copilots. So let's talk about that in a bit more detail in terms of what Claude does well and what it doesn't do so well. So when we use Claude, we do get very fast summaries. It's very accessible to use as well. So it's going to use natural language. We can talk to it in a very human way to get our answers out. We haven't got to code it in. We haven't got to use maths to get an answer. We can do it very humanly. And usually when we do that, we get very accessible insights from the output of this. It will talk to us in a very plain manner. It'll try not to overcomplicate things, and it'll try to appease us. And it may even throw in a couple of graphs, a couple of charts to back up what it's saying. So a very pleasant experience, very fast, and very easy to do. And Claude's very good at this at a basic level. But there's a lot of stuff we need to think about in terms of what Claude can't see. And this sums up the Gen AI in general, in terms of where the fallacy happens, is that we haven't given any context. So when we spoke about everything the data set fell short of earlier, it's all context in terms of how the data was captured, how the data was prepared, how there was problems with the apps in that southern region that was driving that higher churn rate. Stuff like Claude and these predictive algorithms, it can't trust what you haven't given it. It can't analyze what you haven't given it. So we haven't told it was captured via web poll. It can't intrinsically understand that there might be bias there in terms of how you've done it, and tell you there might be bias then how you've done it. If we take data away from that data set via our data preparation, it can't make interpretations based on that. It's usually better to give it the whole data set and let it make its own choice based on context in terms of that, if it really is an outlier, or whether it should keep that data set within. Also, it's going to trust you intrinsically, and it will trust you entirely when you give it these data sets. It's never going to question you really in terms of saying, "Whoa, can I get a bit more context on what you've given me there? Can you tell me how you capture this data?" It's never going to ask you that. These large language models, such as Claude and GPT, again, they're made to serve us. They're made to be very easy to use, very applicable, and they're made not to really question us too much, as to keep the adoption pretty high. So let's move on and take, for example, we've gone back to our Velvet Real Cinemas situation, and we've pushed that data set in. We've made a predictive model, or we've given it to Claude, and it's pushed out that we need to target 66 plus in the southern region as our biggest churners. So we can make one business decision there. So we target those 66 plus customers in the southern region, and we reduce spend elsewhere for our attention spend. So we're going to use our marketing. We're going to give discounts. We're going to give offers to those people in that 66 plus customers in the southern region, try and make them stay. Why would you do that? because the data clearly shows that the highest churn. Claude said the same. So we've gone through two different data sets, two different ways of making a choice, and it's been backed up twice, but they've both been misled by the same biases. Now, by making this one decision, we also intrinsically make a second big decision by deprioritizing everyone else. So we stop our proactive reach to anyone below 50, below 66 in general, especially in the North and West. As when we looked at a data set, remember, they only had a churn rate of 18%. So nearly half that at the South. And again, why we do this? Because the data clearly show the lowest churn, and Claude data said the same. It backs us up. Where the two different AI sources, and they both said the same thing. They're both misled by the same biases because we weren't keeping ourselves aware of where bias can enter into our systems, and we weren't actively trying to negate that bias. So, hypothetically speaking, again, we could have made that choice. That combination of 6 was safe. Overall, had a 42 apparent churn rate in our data set. But in reality, when we keep in contact with the fact that we didn't capture everyone in there, and the people in person as well could be into it, but that 6 plus Southern customers were actually our longest tenure and highest spend customers, and they were the most loyal customers we had. And we spent budget for retention, and customers never going to leave anyway, and then we unfairly impacted other customers. So what have we done? We spent money on people who weren't going to leave anyway, and didn't spend money and unfairly impacted other customers, which were thinking about leaving, and probably drove them away by doing so, because they'll see other customers getting these benefits, getting preferential treatment, and go to other cinemas instead and get the love there instead. So hopefully that kind of shows a bit of a bias at how we come into our data sets. I'm going to take a second as well, talk about another secret bias, you could say. And this is just me kind of being nerdy in terms of how we do this. And the fact it can be a lot more built-in bias in terms of what models we choose when we do go ahead in terms of sorting a certain problem. So a churn problem I chose specifically because it has its own intrinsic biases built in by how it does its computations. And that's just by how churn is as a fact. Usually when you look at data sets for churn data sets, so people going to a gym, more people stay than they are leaving it in a gym or any retail solution. And we'll see here, that whole data set I showed you earlier, only 7%, 75% of that data set were churning. And usually an AI model will choose the easiest way of identifying churners. So if it was to predict that not everyone churned, every person we chose to predict for, you get a 75% accuracy. And this kind of leads as well to when we do have a model in place and we look at metrics in terms of assessing how good that model is, we can be misled by metrics as well. 75% seems a pretty good model to me on the face of it, but that's why we have to dig deeper in terms of why is it making that choice? Is it really doing what it needs to do? A lot of the time, we need to use a combination of metrics to really dig out the bias and dig out it's really doing the best thing and how well that'll work in production. So I'll stop for a second there in terms of seeing if there's any questions anyone's had as I've gone along the way, or any questions off the back of that before I get into the tail end of the talk. Anyone?
I'm not seeing any in the chat.
Okay. If not, I'll push on then. So I've spoke about how bias come into our data sets, how bias come into our solutions, how it can affect people on a grand scale in terms of predpol, but also on a more minute scale in terms of how we can deal with people who may want to churn or not, for a smaller kind of demographic of cinema goers or not cinema goers. It's more customer experience there, so the damage is more on our bottom line in terms of when we're doing things, but the impact can be very severe as opposed to as shown in that predpol situation where people's lives were seriously affected by the use of AI. So let's talk about how we can employ a really practical, useful decision framework to help us negate these biases. So Microsoft has a responsible AI framework that they push out to ensure AI systems are fair, transparent, accountable, reliable, secure across the entire life cycle and not just deployment. That's the kind of quote line they give to this framework. And what it breaks down into is 6 principles they want you to adhere to, and they think you should adhere to. And there's a quick summary of kind of how they go about. And there's whole documentation on the Microsoft websites in terms of what's there, how they think you should do it, and they have their own suite of tools in terms of how we can impart fairness, impart privacy and security in the data sets, be that in Fabric, in Azure Machine Learning Studio, in the Azure Foundry. There's tools such as FairLearn. There's transparency and accountability tools in there, but that's not what I'm going to push you today. It's very codey. I think more what I give you today is a series of questions broken into 4 stages they can use to kind of question as you go along and make sure we're keeping bias in mind and make sure we're keeping what ethics might we be impacting as we go through. So I'm going to call out at the different stages what principles we're going to corner on this. So my first stage I talk about is pause. So pausing before we build. And this kind of encompasses fairness, the inclusivity and transparency. So when we come down to it, we should really ask the question, who is representing this data and who isn't? So going back to the Velvet Reel Cinema example, the people representing that data set were the people using the app, and the people who weren't were the people in person. So again, of a large demographic, we were being biased to a certain age group. So we need to stop and think, who have we biased? Who have we not represented in our data sets? And what assumptions are we making already? So I took a quick 5-minute analysis of our data set, and we were already assuming that 6 plus southern regions were going to be our churners. As well as thinking, what past decisions shape this data set? So it's that decision to collect via just the app, decision to just keep our digital data as what we're going to use as source of truth. And then thinking about when we do go for this, what could the system get wrong about people? What assumptions is it going to make about its data set as we go through that we may want to negate as we go through this build? So the second stage, we build. Something we keep in mind while we're building. So what decisions will this eventually influence? So we need to keep in mind that when we're building this, the output is going to input how we're going to spend our retention. So it's going to affect how the company acts towards our customers, but also it's going to affect how our customers are treated and how they're going to think about our company at the end. Are we going to make sure that they improve the accuracy of the model? So it may be the fact, again, with the example earlier where 75% was very accurate, but it was biased in that it was making the correct decisions every time. So sometimes you may find that striving to get the most accurate model isn't the end goal of what we're trying to do. We're trying to get improved outcomes of people via modeling this and not trying to get the most accurate model. So we need to keep the human in mind when we're doing this sort of stuff. We also need to think what behaviors is encouraged downstream. Again, going back to Velvet Reels, it's going to encourage discriminatory retention spend. So we need to keep it in mind in terms of what the actual impact of what we're doing is going to do. And we need to keep in mind, could this data set be misused? Could the AI model we have be misused? How could it be misused? Could people overtrust it? If they do overtrust it, what's the impact of that overtrust? So we need to keep this in mind and make sure we caveat it as we go along. And how can we combat that when we build? The third stage, release. So thinking before others act on it. And this comes into our accountability, transparency, and our privacy and security. So when we do release a data set or an AI model, who's allowed to see that? So a lot of the time, we may, in the fact, just release our churn models data to marketing. We may just release it to senior management. But we may not want to release it and let customer services see it, because they may deprioritize people at 6 plus in the southern regions for support. They may not spend as much time helping those customers out, as opposed to people between 18 and 35 in the north or west, because see them as people that need to be kept on, need to be acted upon to keep them happy. We'd think, who's allowed to act on it? So we know marketing would probably be that stream that's going to act on it. Could they do something which is detrimental to the company, that is detrimental to people? So this is more a difference between our Velvet Cinema example and Predpol. Who's allowed to act on it? Marketing, in terms of how they're going to turn their spend on offering discounts, is not as big as impact as Predpol, where police are going to go and arrest people and potentially ruin people's lives. So we need to think about that. We all need to think about how people interpret this outcome. Going back to Predpol again, these police officers are going to assume these large black communities, in that example, are more prevalent of crime. They're going to make that association with criminals and ethnicity. And it's, as I said earlier, it's a self-fulfilling prophecy. So those thoughts are backed up by the actions of what's happening. And moreover than not, we need to think about who's accountable for the outcome of what the model makes, what a data set makes. Is it the people who own the data? Is it the people who have created this model? It can't be the model itself, because that's not a person. It's not an entity. Accountability can't rely on something that doesn't exist, really. Is it going to be the senior manager? Is it going to be the CEO? And we need to make sure they understand the ethical considerations going on. We need to make sure there's someone who is accountable for what happens, the outcomes. So we don't have something like Predpol happening where no one took accountability and everything fell through the cracks in terms of trying to fix the problem. And then the final, watch after its use. So after the AI model is live, and we need to watch what outcomes are coming out. And this in terms of reliability and safety. Are outcomes changing over time? Are the wrong demographics churning from what we expected? So have we, by implanting this model, changed the churn activities of our customers? Are some groups been affected more than others? Going back to Predpol again, obviously certain ethnicities were being affected more than other ethnicities. Did the underlying model or data set change the meaning of the results? So it could be the fact that come next month, we include the in-person cinema goers to our Velvet Reels data set and our Velvet Reels model, and all of a sudden the retention spend would flip on its head in terms of we'd see the truth of the data. Our retention spend would change. And who reviews this and how often? And this is very vital. It needs to be reviewed very often in terms of if a big has happened with data set, just to make sure we're not missing outcomes change over time, to make sure what we have is still relative to the real world. So the data we've input into the model is still indicative of the real world if it was in the first place. So that's a very important piece. So how can we apply this in Fabric and Power BI? So first of all, with the pause, in Fabric, we can add descriptions for column data sets. So this is how we can give context to our AI models. For example, if we knew via the port collection method that the 66 plus age group were underrepresented, put that in the header. So someone like myself could know if we're going to go and use that data set created for me, that I may not want to use that 66 plus under, or I may caveat it to my AI models if I'm using like Claude. If I'm using just simple maths and code to make a prediction model, I'd probably want to do something in terms of standardizing and making it a level playing field for that 66 plus demographic. But also pointing out that I would definitely need to know that digital engagement score correlates with age. I'd assume it, but it's been made very clear by having that description to the column and data set that I shouldn't use that for any feature engineering. Secondly, in Power BI, we could use data profiling. So in a Power Query, that column distribution, so knowing that the 66 plus only populate 12% of the rows, but had a half, 50%, 38% churn rate, you'd probably think if it was called out by the data profiling in Power Query, that we probably haven't got enough data there to make a good choice. I probably want to go back to the business and go back to my data engineer to say, I probably can't use this data set because there's just not enough capture there, or want a clarification that we really have captured the whole demographic there and get more context myself that I can pass on to my models. We also want to document within our Power BI report any known collection methods, how it was done, give context to our engineers, give context to people down the line from our data sets to understand what's happened, the context of data that we can then pass on to our AI models. So really, we want to ask who collected the data and how. I've given a little answer there in terms of is a web pool, and that kind of the context of how the data was collected that we could have asked at this pause stage for Velvet Reels really changes the whole problem as it is and how we progress with building that model. So how can we apply build? In Fabric, we could treat AI outputs as recommendations and not decisions. So for a model or data set where we've got a target retention, we could say that instead of saying 66 plus, we target retention, we say very intrinsically it's AI targeted retention. And also keep notes in Fabric for our models, our versions, our training data, assumptions on our models, give as much context as possible to people using it that we could pass on to AI, or we could pass on when we are talking about the results of our models. In Power BI, use visuals to show how outcomes are changing for such as age, band, and region. When I showed you in the Power BI, that 66 plus safe analogy becomes visible. If you look for it, you can see how it's unfairly biasing in those bar charts. What's allows us to do, it lets us think we are optimizing metrics behaviors and think the who or what is influences our decisions. And we can navigate that and try and beat the bias that we're trying to put into that data set by asking those questions and using these things in Fabric and Power BI. So for release in Fabric, certainly make sure we get the data owners sign off for any data set models which can change outcomes. Maybe even go higher to senior management to make sure they're happy that what is being said by our data sets or our models is being put out there. Are they happy with the truth we're trying to push? Power BI, control access. And I'm a big advocate for this. So not everyone needs to use access to LLMs. It seems to be everyone's throwing Claude, ChatGPT, all the problems and seeing what sticks. And that's a very dangerous activity to be going under in terms of how easy it is to put bias in and how easy it is to affect people by what we do with them. Use your endorsements of Power BI. Don't certify decision-shaping data sets lightly. Again, push up the chain to make sure the senior managers and data owners are happy with what's being said by the data set, by the models. And these steps, they stop people jumping to conclusions, making choices before they've really looked and tried to sort context. Because what people do when stuff comes out of AI, they trust it intrinsically. Going back to automation bias again, we need to critically think and critically question. And via asking these questions and via making it very clear in Fabric and our Power BI applications of AI, we want to reduce that casual business misuse of insights and make sure people are aware of what's going on. And finally, watch. Monitor dataset retreads and monitor the effects of retraining our models. On top of that as well, keep your data lineage clear. Understand what data is feeding into your models and where that data has come from. Again, it allows that data collection methodology to feed through. So the person at the end who sees the output of those models can see very clearly where that data came from and when this data was last refreshed, when this model last retrained to make sure everyone's in the context of how fresh this decision is. Add visuals. So if you have a central dashboard in terms of going back to the real cinema example, how outcomes are changing over time, how people are churning or staying, or how often they are coming to the cinema after we've put those revised retention spends in place. That way we can assess if the outcomes of people are drifting or if some groups are being affected more than others by what we've put in place. And then we can proactively try to combat that and go back and see where we might have got it wrong. So overall, we want to pause, document our assumption data sets. 2, build. Make everything very clear. As we're building, make it explicit what we've done, what's been done by AI, and then test by group as we're going along. Don't just ask for an overall accuracy. Get accuracy per region, per agent, per age band, per digital engagement score banding, just to make sure it's fair in terms of being accurate for every single demographic and not just all the demographics overall. And release, make sure we control who can act and who owns outcomes. There's accountability there, but also we're making it reliable and safe in terms of what's going to happen with what we've made. And moreover, we need to monitor impact, not just performance. We don't really care how well it's doing. We want to know how much is it impacting who's being affected by our decisions. So I'll try to wrap this up with one last question in terms of, do you think deeper insight into AI ethics would help your business? I'll give it to you there. Okay, I spoke for a bit longer than I thought I was going to there. Apologies, everyone. But I have got to the end of the talk. So open for any questions. If you want to drop them in the chat, I'm more than happy to address them here. If you want to add me on LinkedIn, I'll also talk to you outside of this. My email, very easy to find, lewis@purplebrooksystems.com. But yeah, we've got a couple of minutes now. Any questions, I'd love to respond to them now. In this case, wouldn't this be fine since beginning before training data set to have checked representative samples of the population? Or training data set to have checked representative samples of the population. Just elucidate a bit more, Paula, in terms of what are you checking for? In terms of the bias? I'm going to try and hazard a guess. Are you saying you're doing sampling of certain demographics of data set? I suppose it depends on what you're trying to do with that data as well. Yeah, so this again, yeah, you've hit the nail on the head. In terms of the web collection method, they didn't collect everyone. So they didn't get a representative sample of the population. So I think that's what I was trying to say, is in terms of before we pause and we go in, check, have we got everything? Is that a representative sample of our population? You're very correct there, Paula. That's correct. You want to go, again, using that framework I've said, pause and check if we are capturing everything we should. It should be intrinsically suspicious that just 12% of the data, we know there's a lot, especially in the UK, of people of that age group that use this sort of services. So yeah, I think you're very correct there, Paula. Yes, we can share the slides. I will share the video as well. Is it practical to implement some sort of virtual agents checking this kind of bias? You can do. People do this. Again, you can build and do it for yourself, but do you intrinsically trust? I mean, I showed with Claude, it can miss if you don't give it the context. And if we just get it to point at the data sets, so I didn't really do it in the most robust way, used that virtual agent in the Claude to kind of double check my thinking. Now, I'll admit, I did it the way which I kind of semi-knew it was going to make the same assumptions as me. But you can, if you train it very thoroughly. And I would still want a human in the loop to check against that bias, to check that the virtual agent is right, ask the right questions. I'd like it as an agent to kind of use that framework I'm saying today and ask that questions of you as you go along. But it's a good avenue to go along. It adds that second layer of trust in terms of you've tried to combat that bias. So yeah, it is a way you can do this. It just depends on how well you implement that virtual agent. How well have you trained it? How well have you prompted it to look at certain things and to pull out that context? But it still falls into the same trap of it can't see what you haven't given it in that regard. They may put it out. Yeah, it's not foolproof. Yeah. Again, it falls in the same trap. It's still an AI system. But there are cases like it's a good second step. It's a very good second step if it's done right. Cool. So I will wrap it up there. Thank you for all coming. I'm always free to chat to you. Again, look at my LinkedIn, go to the Purple Frog blog, find my email. I'm more than welcome to talk to you on LinkedIn as well. So everyone have a really great rest of the day. Thank you for coming and attending.